Polynomial functions follow this format that you can see up here, where it starts with the highest degree exponent. So this might have been like x to the fourth, and this might have been x cubed and x squared, and then I'd go all the way down until I had no more exponents. And then the number in front of them is just their coefficient. So maybe it was 5x to the fourth, so that would be a 5, and 2x cubed or something like that. The coefficients, the a's there, are real numbers, not equal to 0, and n is a positive integer, so there's no negative exponents. A sub n is called the leading coefficient. When we are looking at examples of these, so you can see through here, we have 6 different examples. Each of them vary a little bit in length, but more importantly, their highest exponent changes. So I'm going to actually start at the bottom. I can see that the term with the highest exponent, or the highest degree, is that 9x to the fifth. Well, the 5 would be the degree of the polynomial. The 9 would be the leading coefficient. When I look at the one above it, negative 3x to the fourth has that highest exponent, that degree of 4. The negative 3 is the leading coefficient. Above that, negative x cubed is the highest one, so my x cubed, my 3, that degree is my degree, and the negative 1 is my leading coefficient. Above that, I have the 12x squared is that highest powered term. The 2 is the degree, the 12 is the leading coefficient. Above that, I have negative 5x, because that does have a degree of 1. Leading coefficient there would be negative 5. For the top one, it's only got the 4. That is a degree of 0. It's considered a constant, but the leading coefficient would then be 4. Notice too, when you look at these, that the degree in each one's like they drop as you go through them. So as I look at, let's go down here and do the very bottom one. The first degree is a 5, then 4, then 3, then 2, and then there would be 0, but they go in order from highest to lowest. That's how you know it's in standard form. We have a couple of different parent functions. We've talked about several of these. Constant would be something like y equals c. It would be a straight across horizontal line. Linear, that parent function is y equals x. So those diagonal lines, that was not great. It goes through the origin and through the point like 1, 1, 2, 2, 3, 3, and so forth. So it's clearly as close as I'm going to get that with my finger. Quadratic, we've seen a lot of. Those have the shape of your parabola. It's y equals x squared. So more like that. Cubic, we've seen a little bit. Oh, let me try that again. It's going to be more like a squiggle looking shape there. All of these are type of polynomials. Now, some we haven't seen as much are your like quartic or your quintic, and you know what? Their parent functions actually look very similar to the ones we have seen. So a quartic, since that's an x to the fourth, it looks very much like that x squared, like that quadratic. And your quintic, which is y equals x to the fifth, looks very much like your cubic. They have that same shape. And the reason that they have that same shape is both when I'm looking at my cubic and my quintic, their degree, the 3 and the 5, those are both odd numbers. But when I look at my quadratic and my quartic, their degree, the 2 and the 4, those are both even numbers. That actually tells you what your end behavior is going to do. So when we are looking at end behavior, I'm actually going to slide down and look at this first. If you have an even degree, like we just saw the quadratic, the quartic, those went the same direction, but we need to figure out, are they both going up or are they both going down? So you always are going to start with the right side. That's going to tell you your is going to be based off of your leading coefficient. So we want to start there. So if it's a positive leading coefficient, the right side goes up. If it's a negative leading coefficient, the right side goes down. So it's all about the right side and that leading coefficient. Once you have that leading coefficient, then you can do your left side. If the degree is even, then your left side will go the same direction as the right side. If it's odd, it will go the opposite direction. So when I look at like a quadratic, that's an even degree, they either both went up or they both went down. But when I looked at my odd degree, so my cubic or my quintic, one was going up and one was going down. So they would go opposite directions. So looking at 7 and 8, on 7, the right side goes down. So that would be a negative leading coefficient, which sometimes we will abbreviate as LC. Whereas on the number 8, the right side is going up. So that's going to be a positive leading coefficient. Then it asked about your degree. Notice that on the left side, or sorry, on 7, the left side is going the same direction. So that is going to be an even degree. Whereas on 8, the left side's going down and the right side went up, so that's going the opposite direction. So that is going to be an odd degree. With that, let's see if we can't do our in behavior for these previous ones, 1 through 6, because it did say look at your calculator, but we didn't have a calculator available. So first off, as x goes to infinity, that just means the right side. So all of these first ones are just asking for the right. As x goes to the negative infinity, that would be your left side of your graph. So all of those are just asking for the left. I'm going to look at my leading coefficient. It's positive. So my right side is going to go up or to infinity. Because my degree, that 4 there, is even, my left side is also going to go up or to infinity. Looking at number 3, leading coefficient is 2, which is positive. So that means the right side goes to infinity or goes up. The degree is 3, which is odd, so they're going to go opposite directions. So the left side is going to go down or to negative infinity. On number 5, your leading coefficient will be that -2, so negative, which means the right side is going to go down towards negative infinity. The exponent, the degree there, is an even number, so the left side is going to do the same.